Welcome to Gosh Acki-Nacki special event. Today we're going to unveil a groundbreaking blockchain architecture. But before we do that, I would like to thank the amazing Gosh team for doing an impossible. Thank you very much. I would also like to thank our supporters and investors, without whom that would not be possible. In 2009, Satoshi Nakamoto mined first Bitcoin block and started the decentralized financial revolution. He brought finance back to the individual hand. 5 years later, this guy, Vitalik Buterin, at a Miami Bitcoin conference, said that he wants something more from this financial network. He wants to run some kind of applications on top of this network. And to run these applications, he needs an execution environment, a computer that could be decentralized. So he said, Bitcoin is not enough for that. We need something else. We need something more powerful. We need a Turing-complete virtual machine. We need something we can run any kind of program on top. And he called that world computer. What kind of applications he thought he would run on this world computer? Well, he actually gave a list. So he said some financial applications may run on that, like some financial smart contracts or insurance or maybe decentralized prediction markets. But he also said there could run non-financial applications. It could run storage, decentralized storage. It could run decentralized social networks. 2 years ago, Vitalik Buterin gave an interview, and he said, and I quote, "I still believe Ethereum could be the world computer." So apparently, it isn't. And it seems that we kind of abandoned that vision to create the world computer. This guy didn't. 2 weeks ago, Satya Nadella, CEO of Microsoft, pronounced on Ignite stage that Microsoft Azure cloud is a world computer. And if you think about that, he's kind of right. Because there are millions of people, actually billions of people, who are using his world computer. It's not decentralized. It is very, very much centralized. But why it happened? Why we, who coined the term world computer, couldn't build one? Well, let's examine what is running on our world computer, on the blockchain today. 90%, and we're being large here, of all the applications run on all blockchains today are financial applications. Only a tiny piece, less than 9% actually, is non-financial applications. Most of that is thanks to the Filecoin and other storage solutions. So why so many years passed and we couldn't build more applications which are not financial? Well, let's talk about that. Some people said it's because of seed phrase. Some people said that these 12 words that you need to create the wallet on the blockchain, it's actually what stops most of the people to use it. We actually don't believe in that. We don't believe in that. Because why it doesn't stop them from using the other financial applications? And also, there are many tools now to manage the seed phrase. There are hardware wallets, there is a wallet abstraction, and so on. It seems that's not the reason. Let's examine what we would do. Let's say we build some kind of a social network, let's say like Instagram, decentralized, okay? Well, you want to upload the photo to this decentralized Instagram, and you hit the button, like post. What would happen if you do that on the blockchain? Well, first thing, you would need to pay. You would need to pay. For every post you do on this decentralized network, you would need to pay. But that's not all. So you paid. And then you wait. You wait, and wait, and wait. The picture doesn't appear immediately because blockchains are slow. They're painfully slow. Over the last years, many guys like in our industry recognized that problem and they tried to solve it. How they solved it? Well, there was like Ethereum that said layer 2s. We do a layer 2s. That's our scalability solution. They're cheaper. They can run more transactions. Then Solana came. Solana said, oh, we will do very fast. We will do like immediate 250 milliseconds block time, something like that, and 65,000 transactions per second. Then there is a Ton. Ton achieved 100,000 transactions. Then there is Aptos with 150,000 transactions. But there is one thing that they all have in common, which we believe is the real reason why nobody uses non-financial applications. And that's this thing. You see, our research says that people are ready to pay per transaction only when they transact with finance. If they move the value, if they move the money, they're ready to pay some portion of that. If they invest into something, they're ready to pay a fee. But they're not ready to pay anything per transaction on a non-financial application. They want to post a picture on Instagram. I'm not ready to pay for it. So what kind of thing we need to do to eliminate the gas altogether? If you think about today's blockchain architecture, it's actually look like that. It's an 8086 processor, ancient Intel processor, one-threaded. So when we're trying to build the financial applications, that's fine, it works there. But when we are trying to build something more modern, something that people want to use, right, non-financial applications like social media, that's not enough. It just cannot run it. In a way, we are finding ourselves exactly in the situation where this guy found himself. Steve Jobs tried to build a personal computer with this amazing interface. He knew exactly what kind of interface needed for personal computer to be used by many. And he tried it 3 times. Lisa, Macintosh, then the next computer. On next computer, he said, I know exactly, we built this amazing operating system that people will be thrilled to use. And what computer we're going to run on? Well, there is no such computer, so I build one. So he built one. He built the next computer. Nobody bought it. Nobody bought it. $8,000 was too expensive. Nobody could buy it. So he waited additional time for when the industry was ready to give him that. And that is what we need. We need a processor that can run simultaneously, multi-core, multi-threaded applications. And we need it to be decentralized. We need something like that. You see these guys there? That's what we have today. That's what we need to build. Can we do it? Well, first of all, let's talk what we need to do. So I think there are 4 parameters that we need to have. The fast block production, so that people don't wait too much. Then we need a massive amount of parallelization. We need millions of parallel executions because we need all of these people not to wait. Then we need a sharded state because the more people use it, the shard will become larger and larger, basically the storage. We need a lot of storage, and we need to be able to shard it like Microsoft Azure databases sharding it. And then, of course, we need the high security, right, because we're a blockchain. So you see, many tried, and some of them achieved some of that. Some portions of that, someone did great security, like Bitcoin, then Ethereum with this new sharded architecture, and then Ton with parallel execution, Solana with the fast block production. But no one quite got it to do it all in one, because we need one processor like that. And today, we will show you that processor. So let's say it's a game. And actually, it's a horror game, as you might guess. This horror game actually has parameters. So let's talk first what it can do. The block time, block production, is 330 milliseconds. Is massively parallelized. It's almost infinitely parallelized. You can run as many block producers as you want. The finality is less than 1 second, and the security is orders of magnitude more than that of a Bitcoin. And it also has very interesting property. It's actually self-adjusted. It reacts to the parameters of the network and adjusts its properties to match the security guarantees. All the network participants agree periodically on the security level that they want to achieve. And depends on the parameters of the network, for example, how many participants are there, the network itself will change its own parameters. No programmers needed. It does it by itself. It's self-adjusting. So let me introduce you to its actors, like who is participating in this game. I will actually try to explain you how it works. Don't be frightened. I don't think you need to be a computer scientist to understand. It's that easy. It's very elegant. So first of all, block producer. Well, this guy apparently produces blocks. And that's all he does. He produces blocks very fast, very, very fast. Sometimes, maybe, this guy wants to attack the network and to produce malicious block. So he inserts some kind of transaction that, for example, wire all the money in all the network to his wallet, let's say. And he produced that block. Okay, so we call it malicious block producer. Then there is a block keeper. The block keeper is the guy who receives the blocks, and it doesn't care. Block malicious, non-malicious, just receive the block. When he receives the block, he sends an attestation that I received the block and send it to the network. That's all he does, except for one tiny thing, one small thing. He also rolls the dice. It's a very special kind of dice. It's actually even not rolled once, but we will talk about that later. So he rolls the dice. What happens when he rolls the dice? Sometimes this dice will fall, and he will need to turn into this amazing creature. And it's actually a she, we believe. Acki-Nacki. Acki-Nacki is a girl who will check the block. She's actually going to verify the block. And if the block is not malicious, she'll set an ACK, acknowledgement, we call it in computer science, to the network. And if the block is wrong, malicious, she will set a NACK, not acknowledged, denied, certificate. What happens if she's saying the block is bad? Well, it's a horror. It's really horror. Because all the network turns on the malicious block producer, slash him completely, take all his money, burn it, it's important, not take it, burn it, and kick him out of the network. And that's it. That's it. It's that easy. It's super easy, super elegant. It's amazing, actually. What is the proper, why did we do that? What it achieves? Well, it's actually the network which is optimized for optimism. It's a very optimistic network. In fact, it's a very, very good game. Because what happens when nothing wrong happens? I'll tell you, okay? So let's repeat it. The block producer produced the block. The block keepers just receive the block, set an attestation that they received the block. Some of them, like all of them, rolls the dice. Some of them will become Acki-Nacki. Check the block. It's okay. Send the NACK. That's it. Send the ACK. That's it. It's just 3 steps. That's why it's so fast. That's why it can achieve massive parallelization. So, but how secure is it? Well, that's what happens if, and it's a big if, we will talk about that today, if someone, some of the block producer, try to produce malicious block. Well, it goes to the rolling the dice, Acki-Nacki, Acki-Nacki check the block. It's a malicious block. Then the network stops. It kind of slows down to mitigate the attack until it resolves itself and continues. And you say, okay, so but that's slow then. Well, it actually never happens. We claim it will never happen. Never. But before we go there, let us see why actually we build it, what it gives us.
Hi. We are recording this on December 9, which is 1 week after the event. So we made some improvements, but also primarily because we wanted just to make a demo smoother. And I'll show you again how fast Acki-Nacki is, and that's the main purpose of the demo. So I already create a bunch of things, and the purpose of this is not to show the Gosh actually capabilities. So I will do some tasks, like for example, let's create a DAO. Demo DAO. Like 1,000 tokens. So what we're doing now is creating the DAO on Gosh, and which runs on Acki-Nacki. Now this implies deploying a lot of smart contracts actually. There's a whole system with all the functionality which is deployed right now on chain. So it's not one contract that you just boom, it's done. Okay, so I even didn't have time to kind of walk you through so you can see that this is like the DAO with all the members, which is right now just me, with the ability to store files, with the hackathons grants here, task system, all of that, Ethereum layer 2 supports, all of that needed to be deployed for this DAO, and it took a few seconds, right? So okay, I already have some DAOs that I played with, so it has some. So I created Acki-Nacki DAO, which has me as a member. I also created tags. So let's see. Let's invite some new member to this DAO. Right, Satoshi. Again, I can invite whole DAO. I can invite the person. Satoshi has a DAO because obviously, like we create DAO for every person that joins. So I created Satoshi, and that created a DAO for him. But let's invite just Satoshi with 20 karma. Let's invite. Satoshi sounds like a good idea. By this member, and okay, we need to vote for it. Let's vote. So I'm on the lone member, so I'm voting, and boom, it's done. So we have proposal accepted, and well, let's see. Yeah, we have Satoshi now, right, with 20 karma. So it has a token balance of actually more than me, even because I have also 90 investing. But that happened because I created task here and performed it here. So okay, I have some tags here. Yeah, I have an admin tag, which gives me 150% of power on everything that admin, that every commit that admin tag is on. So let me add the admin tag to me. So adding admin tag. So it will give me some more voting power on the decisions where admin needs to vote. So let's create this. That we need to vote for this. So okay, so I vote for this. Well, we need Satoshi also to vote. So I'll go to Satoshi. And I vote from his account as well. You won't see that, but I'll just do it now. So yes, I'm voting for Satoshi. Yeah, so we have it's accepted, right? So now I need to have. I think I have I have an admin tag now. So if I create a repository, let's say I want to create a repository. Let's go here, create new, and let's say We have a admin repository, and we add the admin tags to this repository, create repository. Just want to say, creating repository is a very long task. It's creating many smart contracts because it's kind of repository, the tree of the repository, all sorts of objects. So I'm voting for this. As you see, I had a 20 power, but now I voted with 30, and I voted with 30. The reason for that is because I have 150. The stacks give me 150%. So now I had like 30 votes instead of 20 for this stat, despite the fact that I have only 20 karma. Okay. Well, I think okay, maybe let's create some milestone again. So let's create some milestone. That will be milestone 2, and let's put me as manager, and give me like 20 tokens as a reward, and it will be admin repository, and the budget will be, I don't know, 60 tokens. Let's have some vesting rules. So I'll get it in 12 months, and it will vest over monthly. And let's create this milestone. Okay, milestone is also, we'll need to, boom, done. Let's vote for it. Boom, done. We need Satoshi to vote for it. So I'll go to vote for Satoshi in different browser, and Satoshi is voting now, and boom, done. All right, you see, so it's accepted already. Well, that's how fast it is. Really, okay, let's add some files. We created some admin repo here, and let's add some files. So I have some file which let's put inside. This is admin file. You won't see that, but you will see it in a second. Okay, so let's drag and drop some file here. So I'm dropping it. So you can see that here started all sorts of deployment smart contracts here, like trees, snapshots, diffs, commits. It's boom, done. That's how fast it is. This is incredibly fast. It's faster than Solana, and it's more secure. So this is admin file. Okay, I can put some comments, create some comments. Boom, done. That's what user expects from the modern application. That's what you would do. The same thing in GitHub would look like that. You would see in Microsoft Cloud would look like that. That would be the response times, and we are achieving this response times in a blockchain with Acki-Nacki consensus. That's how good it is. So let me check. Let me change something in this file. Let me add a line. You won't see that again. Adding a line I write in the file and save it, and then let me drop it here. Just the same file. Thus, just replacing it. And what will happen? It will recognize that's the same file. It will open a file and it will apply diffs on chain by validators. The diffs are applied on chain. There's nothing going on the server or locally. It's all on the blockchain. So done. So it's replaced it. Now we see that there's a version of this file because, again, it's a full implementation of Git. So we can see the version of this file. This is the version. These are the changes. Okay, adding a line. That's what I did. I added a line, and we see it here. If we go, of course, inside the file, well, we see this is the admin file, and this is adding a line. This is what I added. Okay, so again, thanks for this, and boom, comment. Perfect. Okay, so that's how fast it is. It's incredibly fast. It is just amazingly fast. Again, we can do unlimited number of members in this, as I already voted before, so that that we see some activity here. You can create hackathons and grants, but there will be, we will talk in separate occasion about the Gosh and its functionality. But what I wanted to convey today is that how fast this thing is. It's just incredibly fast. It's just the same user experience that is expected by the user from any application, and decentralized application is no exception. And except for Acki-Nacki consensus, I don't know any technology which can do the same, being scalable and that fast.
Yeah. What we're able to do here is to bring like a normal interface, something you would expect from like GitHub or any other interface like that, with like user doing a lot of things in parallel, and doesn't expect to pay for it or like wait hours to do that. The difference, actually, we started with creating this Git on chain 2 years ago. And what happened was that, okay, we did it for free, and we ran it on Tone architecture, which was the most scalable at that time. The problem was that let's take one single user. And this user wants to upload one repository, Linux, let's say. A Linux repository with all the history. It's 50 million objects. What happens is he pushes the buttons in the GitHub running on Microsoft Azure, and it takes him some minutes to do. When he hit that button in blockchain, he waits days, not minutes, not hours, days, sometimes weeks, for this repository to be uploaded. It doesn't matter what blockchain you use. Absolutely doesn't matter. Okay? So we needed this processor to be able to process that amount of transactions that the user expects from a decentralized cloud, like what they do with the Microsoft Azure right now. So there are 3 more examples I want to bring, something that we're doing right now. First of all is a governance blockchain association, which runs blockchain Internet Governance Forum called Dynamic Coalition in United Nations. And United Nations has chosen to build that as a DAO. And this DAO is going to run on Gosh. Well, why? There are many DAO platforms started in 2017 and later. But if you look at them right now, like completely, almost all of them went out of business. And the reason for that was, well, DAO, you say. DAO is one of these non-financial applications that supposed to run the blockchain. Well, the reason they went out of business is because they had a DAO, all right, which was a governance, decentralized governance, but they didn't know of what they want to govern with this. You had to create DAO there, and then create your process somewhere else, and try to, connect the two. It doesn't. It doesn't connect. Nobody used that. When we say we give you the possibility like to take this operating system, decentralized operating system, and build some kind of a process. In case of GBA, an Internet Governance Forum, they work on policies and some projects and some tasks and files. So we give them the process that they can use on-chain and then governance on top of this process. So it's kind of a built-in. The second use case is Triscale. Triscale is a great project which is doing environmental credits and biodiversity. And they cooperate with Malaysia Trust, which is a standard in biodiversity. So it's actually a peer review process. And they want to make this process decentralized. So what they're doing, Gosh is going to build them, and we're actually going to show that in Davos in January. We're going to build them this process of biodiversity project peer review, and then decentralized autonomous organization on top of that. And the last one is Devote. Devote is amazing application. It's a cryptographic voting on a massive scale using zero-knowledge proofs. And you can run it. In fact, they are participating in several national elections tenders right now with Gosh. What it gives is anonymous voting on a massive scale And every DAO on Gosh will have that ability, and you can run a DAO on Gosh using the Acki-Nacki decentralized processors for, let's say, 100 million people, which would be the whole nation. So the last questions remain is, that's all nice, that's all beautiful, but how secure it is? We said it's all secure. So we compared that with Bitcoin, but that was too easy. We ran the calculations of the probability of the attack on the Bitcoin network against Acki-Nacki network. And it was like we were orders of magnitude more secure than Bitcoin. So we said we need to find something else, something more interesting, something like the probability which is much lower than the attack on the Bitcoin, what it could be. So we said, well, how about the end of the world? How about the probability of the end of human race? Because that's the most probable effect of it's the most probable outcome of the human race, right? So we ran comparison with the probability of a comet hitting the Earth with the catastrophic consequences against the probability of breaking Acki-Nacki consensus. And to tell you more about this, I would like to invite Andrew again to say a few words. Go ahead.
Thank you, Mitya. So, as Mitya already described a few points how our algorithm works. In this case, for security, we decided to choose two algorithms. One is to ensure that at least one Acki-Nacki will be for at least one Acki-Nacki will be for each block produced. And the second algorithm will ensure that no producer would ever know if there would be some other Acki-Nacki. And for one, to actually like try to calculate who will be the next one, whatever, it will take an infinite amount of time. This is based on the like trying to order a deck of cards and make sure that the next card will be something for each particular block. And block producer will not have that knowledge. He will just show, okay, this is the card, and whoever in the block keepers has this card, please check that, become Acki-Nacki, and ensure that this block is correct. The second algorithm, pretty much the same. Each block keeper rolls a dice and checks if he will need to become an Acki-Nacki for this round. Two of these algorithms ensure that first, security, and second, security. Just multiply this, and you will have this probability. And the second question you may ask, what will happen if some attacker decides to, okay, let's try to DDoS all of the valid or honest block keepers and produce a malicious block? Well, this is the third part, where each block has to be signed. And unless you have this threshold, you will not be able to produce the block, or this block will not be accepted. So if honest block keeper is DDoSed, he will not be able to sign this block. And if he is available, well, he might become Acki-Nacki. So roll the dice, and if you can win against us, then you pretty much can win against the end of the world. Okay, thank you. And yeah.
We're going to release a white paper with all these calculations. That is actually the probability. The Bitcoin is one. It's actually already like gone by that time. So this is the probability of a comet hitting the Earth with the catastrophic consequences. Of course, not every comet. This is the probability of the attack of the Acki-Nacki. So again, you will be able to check if our calculations are correct. But at the moment, we are quite certain that nobody in the right mind will ever try to produce malicious block, because your probability of winning is this. Now, I got some questions before this that asked me, just in September, we said that we will be layer 2, and now we talk about the consensus algorithm. So first of all, I need to say that it's, we are layer 2 to Ethereum, so that nothing changed. In fact, we want to be layer 2 to many blockchains and provide this infinite scalability to any blockchain that want to run some applications, which, for example, requires this world computer to run for free. And then what does it mean for free? It means that you can run the freemium model like you do today in the Azure cloud. Like you deploy your application, and then sometimes you start making money, but not in the beginning, and not for every user action, right? So today we also launch 2 programs. One is a hackathon. It's called Underworld Computer. This is a hackathon that everyone can participate, and we welcome all the developers. It will run for 2 months. It will also have a grant program for scientists who wants to participate in the consensus research with us, and peer review whatever our calculations are, and so on and so forth. The second program is Die Last. Die Last is a validator game. So we invite whoever wants to run a node, Acki-Nacki node, please join. We will try, it will run for about 2-3 months, and we will try to break it. We'll try to break it under a very heavy load. And when we say heavy load, we mean like load that never been achieved before in any blockchain. Something crazy. Before we go, we never run public sale of our token, and we're not supposed to, and we're not going to. We have 100 million Ghosh tokens. Now, the only way to get them is to participate in these 2 events. There is no other way. We also did one small event 2 years ago, so that one counts, and now these 2. Before it will be released publicly on some exchanges. And it will happen. It will happen next probably half a year. We are talking to some of the exchanges, but we are not going to create any kind of ICO, IDO, or public sale of any kind. Thank you very much.